Hello everyone, welcome back. This is Kavita, and in today's video we are going to start with the types of crystal systems. This is from the topic solid state. Now, as we had seen in the last video, what are the various types of unit cells? There can be basically three types of unit cells which we had seen last time. The first one was the simple unit cell. The second one was non-primitive unit cells. Non-primitive unit cells were of three types: FCC, face-centered cubic cells, in which the atoms were not only at the corners but also at the face centers. The second is BCC, where we have atoms at the corners and also at the body center. And the last one is, we're going to draw all the structures. Okay, let us first write their names. The last is end-centered cubic cells. Let us see how these unit cells look like. In the face-centered cubic cells, we saw that the constituents are located at the corners and also at the face centers. In all the three cells, first of all, we must draw the constituents at the corners. Now in FCC, draw some of the constituents at the centers of all the six faces like this. In BCC, you will draw one of the constituent at the body center, and in end centered, you will draw two atoms at the opposing faces like this. So these were the three types of simple and non-primitive cells. Now, what are the characteristics of unit cell? We had already seen this. The first characteristic of any unit cell is the length of the side or edge length, denoted by ABC. And the second is interfacial angles between the faces. Now these interfacial angles are classified as alpha, beta and gamma. Okay, so any two unit cells you can differentiate by looking at their lengths ABC and their interfacial angles, that is alpha, beta and gamma. The angle between B and C is called alpha. The angle between A and C are called as beta. And finally, the angle between A and B is called as gamma. So these are the two important parameters to differentiate between the two cells. Now, there was a mathematician, Auguste Bravais, who with the help of mathematical calculations showed that there are only 14 possible ways in which we can arrange the unit cells, or in which we can arrange the various constituents in three-dimensional space. So there cannot be more than 14 types of arrangements of any atom in space. So Bravais showed us that there are only 14 types of space lattices possible for a given atom or ion or a molecule. And these 14 lattices will be categorized into total 7 types of crystal systems. So there will be total 7 crystal systems. Alright, like for example, if you take the example of a cubical space lattice or a cubical crystal system, it will be divided into 3 types of lattices: simple cubic lattice, body-centered cubic lattice and face-centered cubic lattice. So cube is a crystal system, and simple cube, BCC and FCC are the 3 different types of unit cells or lattices. Let us see the various types of crystal system. The first type of crystal system is the most symmetrical one, that is cubical crystal system. The drawing diagram for this is extremely simple. We'll just draw a cube, and as you can see, in a cube, the edge lengths are going to be equal. So we'll have A is equal to B is equal to C, and also the interfacial angles are going to be perpendicular or 90 degrees. So alpha, beta and gamma are 90 degrees. In this type of crystal system, we will have different types of lattices. So if we see in total, cubic crystal lattice will be classified into type 1 simple cubic lattice and type 2 body centered cubic lattice and type 3 FCC. So if we see, a cubic crystal system has 3 types of lattices: simple, BCC, FCC. The second type of crystal system is tetragonal. A tetragonal system is simply a cube which has to be pulled in this manner from the top. When you pull it up, one of the sides becomes longer. So just have to pull it up. So in tetragonal system, we'll have A equal to B but not equal to C. And the angles will all be 90 degrees. Alpha is equal to beta is equal to gamma, that's 90 degrees. In this system, we will have 2 types of unit cells. And those 2 types of unit cells will be, the first one is going to be a simple tetragonal and the second is body-centered tetragonal. The third type of crystal system is going to be hexagonal crystal system. As you can see, the name suggests we just draw 2 hexagons like this. The second one, join them with straight lines. Just join them first. So this becomes your hexagonal crystal system. And if you observe the structure carefully, you will notice that 2 of the sides, A and B, will be of same length, but C will be longer. So we'll say A is equal to B but not equal to C. And when we talk about the interfacial angles, 2 angles are 90 degrees, but the third angle is 120 degrees. So here alpha is equal to beta is equal to 90 degrees, but gamma is not 90, it is 120 degrees. There is only one type of unit cell in hexagonal crystal system, and that is the simple hexagonal unit cell, where the constituents are only present at corners. The fourth type of unit system is orthorhombic unit system. It looks like a matchbox. So as we know, in a matchbox, all the 3 sides are not same. A is not equal to B, is not equal to C, but the angles are all 90 degrees. In this type of system, we will have 4 types of unit cells: simple, body-centered, face-centered and end-centered. So orthorhombic system has got 4 types of unit cells. The next type of crystal system is going to be rhombohedral crystal system. Now in rhombohedral crystal system, it is a distorted cube. Just imagine a cube which we are going to just push it on one of the sides. And when you just push it, it gets slightly moved towards one of the sides, and the sides remain the same. A is equal to B is equal to C, but the angles get completely changed. So alpha, beta, gamma are not 90 degrees. There's only one type of unit cell in a rhombohedral crystal system, and that is simple rhombohedral unit cell. Okay. The 6th type of crystal system is monoclinic crystal system. And in a monoclinic crystal system, we will find that it is just like your matchbox, in which the sides are unequal, but one of the angles, gamma, is going to be changed. So monoclinic is just like a matchbox with the one angle changed. So A is not equal to B, is not equal to C, Alpha and beta are definitely 90 degrees, but gamma is not 90 degrees. There are two types of unit cells in a monoclinic crystal system, and those are simple monoclinic unit cell, and the second one is end-centered unit cell. So if we just tabulate it, the total monoclinic crystal systems have two cells. The last type of crystal system is a triclinic, which is the most unsymmetrical crystal system. Unsymmetrical because none of the angles are same, none of the sides are of same length. A is not equal to B is not equal to C, and angles are also unequal. Alpha is not equal to beta is not equal to gamma. And there's only one type of unit cell in the system, and that is simple unit system. So children, when we just tabulate this result, triclinic will have just one, and we sum up. So total number of lattices possible are 14. So Bravais explained to us that there are only 14 ways in which we can arrange the constituents in three-dimensional space. If I give you these points, how many ways are there in which I can arrange these points? So there are only 14 different ways in which we can arrange these points, and those ways can be any of those 7. Alright, so I'm sure you can understand that in exam, if a question is asked, how would you differentiate between a monoclinic and a triclinic unit cell? So the answer is very simple, just by differentiating them on the basis of their edge lengths and their interfacial angles, ABC and alpha, beta, gamma. Alright, so please remember, revise these concepts, and that's all from this video.